Okay, viewers, next we talk about domain and range of a relation. Okay, so we are already aware that what is a relation. A relation is a set of ordered pairs where this A comes from A, okay, and this B comes from B. Okay, now what is the domain? Domain of a relation. The set of all the first elements of the relation is called the domain of a relation. It is denoted by d subscript r. Okay, mean in dr, mean in domain of relation, we have elements a, which is actually the first element of this relation. Okay, so similarly, if we define the range of the relation, okay, if we define the range of the relation, range of the relation, range is the set of all second elements of the ordered pairs of the relation. It is denoted by r subscript r. Okay, so in the range of the relation r, we have element b. Okay, we have element b where b belongs to b. Okay, so in this way we find the domain and the range of the relation. For example, suppose you have one set A. In this you have suppose elements like 1, 2, 3, and in B set you have suppose elements like A and B. Okay, now in the relation, suppose we have element 1 comma A, 1 comma B, okay, 2 comma A only. Okay, so you see that what are the first elements of these coordinates pair in the relation? This, and this. These are the first elements of the coordinate pair. Okay, so here we can say that in the domain we have 1 comma 2. Okay, in range you have these elements as the second elements. Okay, so here A comma B, it is the range of the relation. Okay, 1 comma 2, it is the domain of the relation, and 2 comma 2, A comma B, it is the range of the relation. So we solve one more example. Okay, suppose that in set A we have element like 1, 2, 3, 4. Okay, and in set B suppose we have elements like A, B, C and D. Okay, and suppose that we have only these elements in the relation, 3 comma C and 4 comma D, suppose. So what is the domain of the relation? The set of the first elements of the coordinate pair. Okay, so 3 comma 4, it is the domain of the relation. And what is the range of the relation? C comma D. Because these elements, they are the second elements of the coordinate pair, so it is called the range of the relation. I hope you people have understood it clearly, that how to find the domain and the range of the relation. Okay. Sometime what happens that we can define a relation from set A to set B instead of defining a relation from set A to set B. Okay. So a relation R can be defined on the same sets rather than defining it on different sets. Okay, so by that I mean that we can define a relation on set A to set A also. Okay, so in this case, suppose that if a set A has n elements, then number of relations from A to A, this is equal to, this time this is equal to number of elements in A into number of elements in A. Okay, so it is 2 times number of elements in A are n, number of elements in A are n, so it is equal to 2 raised to the power n square. Okay, so in this way you can define the total number of relations from set A to set A. Okay, and these are equal to 2 raised to the power n square. Now next we want to study different types of relation. Different types of relation. So first of all we study this relation, that what is a reflexive relation. Okay, what is a reflexive relation? A relation R on set A is called a reflexive relation if A comma A mean the elements of the same form, they are in the relation, and it should happen for every element of the set A. Okay, and if it does not happen for even a single element of the set A, then we say that the relation is not a reflexive relation. We see some examples. Suppose that we have this set A. In this we have elements like 1, 2 and 3. Okay, and here I take one arbitrary relation, 1 comma 1, 2 comma 2 and 3 comma 3, 1 comma 2 and 1 comma 3. Okay, now you see that as 1 is the member of A, so 1 comma 1 it is in the relation, so it is okay. 2 is the member of A, so 2 comma 2 it is also the member of A, so it is okay. If 3 is the member of A, then 3 comma 3 it is also the member of the relation. It means that for every member of A, okay, we have the same elements in the relation, so we can say that this relation is a reflexive relation. Okay, this relation is a reflexive relation, there is no doubt about this. Okay, now we consider one more example. Suppose that we have this A set. In this we have, suppose 1, 2, 3. but in the relation